let me point out this too. Look at what load case we're on. We're on the last load case number 6. So that one change to our model got us through cases 1 through 5. If I want to see what those results are, because there's only one little change, I could delete this last load case back in the load case editor and get results for the other 5 cases. So my focus is on 410 in the Z direction. So abort this, get me back to the input. Again, I'm going to write down what I'm changing. Node 410, a Z restraint. Let's go to 410. And that's kind of complicated there. That's this restraint down here. Here's the restraint that we linearized earlier over here. Now we're down here in this one. And again, it's a gap. I'm going to kill the gap, blank it out. Click the running main. We made 2 changes. And this 6th load case is still giving us some trouble. I'll step through. 4 not converging. And it's just 4, always 4, but a different set. Friction, open, closed in the Y direction, friction, and friction. So the only one that's not friction, easy for me to fool with, is at 312. We already worked with 312, but this is the Y direction. We're lifting off and resting. I'm just going to lock it down, make it double acting, so we'll remove this nonlinear state. Regarding the friction terms, these other 3 terms are having these friction errors. We could maybe get this to pass if I change the tolerance on that friction. But again, I've already gone through 417 iterations where the chances are that somebody will, at the same stopping point, reset these tolerances. So I'm not a big fan of changing it because it's hard to reproduce the results. So I'm going to stick with my game plan. I'm now going to look at 312 in the Y direction. I'm going to write that down. That was a plus Y, and I'm going to make it a double acting Y. Cancel. Abort the run. Back to the input. Find 312 again. That's that restraint there. We have to make it a double acting Y instead of a single direction. Again, these are very simple things to review. Well, let's make that a capital Y. Point 3. I want to look at the load cases again. Remember the first time we ran it, we had trouble with the first load case. And now we are having trouble with load case number 6. Load case 6 is the last one we have to get through. That's win case number 4. Again, in the very first time we ran it, we had trouble with the operating load case. We fixed that, and we got through all of the first 5, and it was only the last one. So what is that win 4? Win number 1 is in the X direction. Win number 2 is minus X. 3 is positive Z. And this is one we're having trouble with, the negative Z win load. So let's run this one now. Again, I've made 3 changes to my model. Simple changes that are easily reviewed, and this one did converge, and now I'm looking at my output. So I have written down the 3 restraints where I had trouble. I'm going to look at all those analyses. We had 6 analyses, the rest are combinations, and I want to look at the restraint summary extended because I want to see deflection and I want to see load in the same report. Now, I've only made changes on nodes 312 and 410. Here's node 312. Now, there used to be a gap on that guide, about 3 millimeters. And in the Y support used to be a plus Y support. Now it is a double acting Y support. Now, if I look at the load in the Y direction, I have an error here. The pipe actually wants to lift off on these load cases, but it only wants to lift off by about 300 newtons. That means my horizontal load is off by the friction associated with that at the most. And look at my X restraint with a gap. Here I see I have no gap. Now, is 3 millimeters a large gap? If you wanted, you could also pull the pipe over the 3 millimeters and stop it exactly at 3 millimeters, see how these change. But if I look at the magnitudes here, these are very low magnitude. I'm not expecting to see much of an error by making these linear. So 312 doesn't look too bad here in terms of magnitude. And also at 410, the other restraint, here I had a Z gap. So my largest load in the Z direction is about 700 newtons. Now it's not moving at all. We have results that are not completely correct, but at least we can see the effect in this specific model of these linearized approximations. One thing that's kind of interesting is you can probably put some of these restraints back. In fact, I'll give you one shot at that. I'm going to go try to put the first one back in. The thing is finding the right restraint to fix. So I'm going to go back to my model, to that very first one, this one right here, and I'm going to try to put that gap back in. 3.175. This might converge. Again, with machines as fast as they are today and the program as fast as it is, it's an easy check to make. Okay, that one converged. So here I'm looking at results, and now I'm going to have my gap back in on the X restraint at 312. If I did a screen capture of those numbers, I could compare these new numbers with the old set of numbers. Here's our gap. I'm closing the gap. Has it changed my other numbers? Well, I didn't save those numbers, but these numbers look about the same. Just to tease the program a little more, we're going to put the second one back in just to see how that works. So we have results, but we want to see if we get back to less question in our numbers. I'm going to go back to this element. I think that's where our restraint is. That's the 410, and here's our gap, 3.175. And I'm hoping that this runs as well. If this does, then we have only made one change to our model. We have a plus Y support that's now a Y support. And this one converged as well. So it's kind of interesting how this works. Now at 410, there's my gap. I got my gap back. The gap never closed anyway. 3.175. So we didn't get much load in here anyway. Kind of interesting how you can put some of these restraints back. Now, the only error in this model is that I have a double-acting Y restraint at 312, and these numbers indicate how wrong I am. I'm wrong at the most 200 newtons. So this is one way you can get your way through some of these non-convergence issues with Caesar 2. You might find another path, but you should have a similar outcome.